All right, let's talk about question 6 for 6.2. Two $1,000 face value bond are both redeemable at par, with the first having a redemption date of 3 years prior to the redemption date of the second one. Both are about to yield 11.1% convertible semi-annually. So that was the coupon rate. So right there. So we have R is equal to R represent the interest rate. R is equal to 11%, 0.117 divided by 2 because it's semi-annual. So let me calculate that number. Maybe we can grab a calculator. It won't give me a calculator. So okay, so the interest rate is half-year interest rate is our R. That's really our coupon rate. The face value, they were 1,000, and the redemption price is also 1,000 because we're redeemable for 1,000. Anything else? The first bond sells for 780.39, pays 8.1% convertible semi-annually. Yield rate, coupon rate. All right, sorry about that misunderstanding. It looks like this 11.7% was the yield rate, so let's call that I. So then the R, which is a coupon rate, is 8.1% convertible. That's for the bond 1. So this has 0.081 divided by 2. That was the coupon rate, which gave us 0.0405. The price, the bond price P is 780.39. The second bond coupon rate is 5.2% per half year. What is the price of the second bond? So let's call the first price is P1. And so now we have our bond 2. Second bond, it has a different interest rate, so the coupon rate is 0.052 for every half year. The first one says convertible monthly, convertible semi-annually. The other one said 5.2% per half year. So what? How would we connect the two bond? It looks like the one they have in common, that they have the same interest rate. So we will look at how does interest rate is connected to the bond price. In the original setting, the bond price is the present value of the future produce. So for the bond price is face value multiplied by the interest rate. We have how many coupon? Two $1,000 face value bonds are both redeemable at par, with the first having a redemption price 3 years before the redemption date of the second bond. So redeemable 3 years earlier. Oh, how many payment? What was the term of the bond? How many years would the bond be? It didn't say how many years. Semi-annually, annually. What was? I guess N would be the problem. Okay, so it looks like we do not know how many. What was it? How many number of the? What was the number of the coupon number payment? Both about to yield 11.7%. No wonder you guys asked for this question. All right. Since we don't know it, we're assuming it's n. So a present value of this is a coupon payment. So we assuming that we have n payment with interest rate I. I is the one we already identified over here. Now plus the final payment, which is plus the final payment, the redemption price is 1,000. It will be discounted for 3 years earlier. So let's assume we're assuming that's for n payment. So how many year? A payment. So the number of year would be n divided by 2 because it's semi-annual payment. So n over 2 is number of year. So anyway, for this first price is discounted for 1.0585 to the power of negative n, because we got n of the half year, or n over 2 is number of year, but n is how many number of payment and how many half year do we have in the entire length. And with that, we can set up an equation to look at the relation between a. Okay, so this giving our equation goes 1,000 times the interest times the coupon rate, which give us 40.5. So 40.5 is the coupon, and a and I goes 1 minus 1.0585 to the power negative n over I, which is 0.0585 plus 1,000 times 1.0585 to the power of negative n. Okay, so this is an equation. We were supposed to solve the n from this equation. Can we solve the n from this equation? If we solve the n from this equation, the second bond price, yeah, we can solve for the n from this equation. The second price is calculated, well, let's call that P2, is number of coupon is F times R, how many coupon payments, its redeem date 3 years prior to the redemption of the second one, so has a longer term. So then the n is 3 years. That means there are 6 more payments. So it's n plus 6. Every year there are 2 coupon payments, n plus 6 corner. And then plus the 1,000 future value, which is discounted for 1.0585 to the power of negative n plus 6. In this case, F times R is actually a different coupon rate, so it's actually $52. So 52. Yeah, anyway, we gotta know the n. Once we solve for the n from the first equation, we'll plug into the second equation. That should be the total solution. Let's see, how do we solve for the n? Okay, so in the first equation, we'll set up this equation. Let's use this. This is a coupon price calculation. We set this equation equal to, you see, n is the unknown, equal to 780.39. So n from this equation and plug into the second equation. Is there an easy way to deal with this? Okay, maybe we don't have to solve for the n. I think what we need is 1.5085 to the negative power of negative n. Anyway, let's let me go back this first. Let's solve for the n. The solving part. We multiply both sides the equation by the 0.0585 multiplied by the denominator. So you have 40 minus 40 times 1.0585 to the power of negative n. And then plus 1,000 times, here we multiply 0.0585 to both sides of the equation. 1,000 times the denominator is 58.5. That's multiplied by 1.0585 to the power of negative n. Right, so this is equal to 780.39 times 0.0585. So we can pretty much calculate the right side of the equation, which is and that was the final result. This and then we can subtract 40 from both sides of the equation. So we can move the 40 also to the other side. So we minus 40, and what's left is only the rest, which is this. Okay, then we find out the common factor. Other than the kind of common factor, what's left is in the parentheses we have 58.5 minus 40, and then outside we have 1.0585 to the power of negative n, which then equal to 5.652815. Alright, so the 58 minus 40 is 18.4. So 1.0585. I'm sure you can solve this a lot quicker, but this is my lengthy process. We got the left side of 5.652815 divided by 18.4. We calculate that just to allow us to eventually calculate the n. This is what we have. Alright, now that equal to the right side. So if you want to solve for the n, you can solve for negative n is equal to this logarithm of what we have, which is this, divided by logarithm of the 1.0585. This should give us a negative number. Okay. That's our n, not exact integer, but I'm using 21. What's the problem? Maybe it's a rounding problem. That's n. So we'll round it up to n equal to 21. I'm using that one as our final solution. So back to this calculation, we'll just calculate 52, a 21 plus 6, 27, corner a, and then we have 1,000 times 1.0585 to the power of negative 27. So that's the price for the second bond. Is there any way to simplify this? I guess that's a little longer way to do this calculation. So let's see the calculation to see if it's right. So 52 times the A, following the A formula. You can also use your BA2 plus calculator. Just set the payment amount equal to 1, and then the present value, future value is 0, payment value is 1, interest rate is the 5.85, and so on. So that could calculate the A a lot quicker. So this is the 1.0585 to the power of negative 27 plus the 1000 multiplied by 1.0585 585 also to the power of negative 27. Let me make sure they'll enter the right way. Oh, this is A, we should divide by 0.585. At least that's what's I calculated. The solution, so I see a rounding error there. How do I fix it? There must be I did a really direct way for the calculation. So if we went with a different way, maybe the calculation can be more accurate. Oh, the coupon rate was 40.5. This is 40.5. That could be one of the factor. So this is 40.5. And that was 40.5. That was 40.5. Anything else? Yeah, the coupon value should be $40.50. So definitely change. So instead of 18.4, we should get 17.9. I'll change this. So let's look at our N calculation. So to calculate that, this calculation that we were supposed to do is the 5.65 2815 over 17.9. Which then give us this. And that replace what we have here. And that replace the N. How did that change the N? All right. 20.27. Okay. Let me use a decimal N instead. This is our N. That'll make it a little bit more accurate. So instead of the 27, we'll do 20.27 plus 6. That will make it 26.27. And also 26.27 for that one. All right, back here. 7 and alright, so let's update our solution with a more accurate n. It actually went higher. So that's not the reason. 21 plus 6 is 27. Let me think about it. I'll come back to it.